Hello everyone. In this video, we are going to discuss about the concept of divisibility rules. Right. There is one more concept of number system. After this, we are going to discuss with LCM and HCF. That will end our number system chapter. Now, the divisibility rules is basically checking, the given number whether it is divisible by certain basic numbers. For example, we are having. Let's start with the basic numbers. I'll just write the numbers 1, 2, 3, 4, 5, 6, 8, 9, 10, 11, okay, and 12, 13, so right up to 14, 15 and so on, right? So now when we are starting, let's have a numbers which are basically, have 2 or the powers of 2. For example, if the number is 2, how do you check whether number is a 2, whether a number is divisible by 2 or not? We just check whether it is a even or odd, right? So that means that basically we will take the last digit of a number and see whether that last digit, whether it is having 0, 2, 4, 6, 8. If a number is ending up with 0, 2, 4, 6, 8, then number is an even number and it will be divisible by 2, right? It is a very simple one. Then if I want 4, right, then the basic rule would be, that is 4 is nothing but 2 square, right? So here since it is 2 square, what I will do, I will check with last 2 digits of a number. If the last 2 digits of the number is divisible by 4, then the entire number will be divisible by 4. That means that if I am having 132, you don't need to check entire 132. All you have to do is take last 2 digits, that is 32. Check whether 32 is divisible by 4. Now you know that 4 8 is 32. So that means that 132 is also divisible by 4. Right. Similarly, if they are having 1 3 5 4, right? So if this is the number, all I have to do is I don't need to completely check. All I check is the last 2 digit, that is 54, and check whether 54 is divisible by 4. And since 54 is not divisible by 4, this number is also not divisible by 4. Next, 2 cube 8. So that means that we have to check last 3 digits of a number whether it is divisible by 8 or not. So that means that if the number is same 1354, all you have to do is you have to take this 1354 and check whether it is divisible by 8, or if it is, let's say 17812 something like this. Okay, all I have to do is last 3 digits and check this 126 is divisible by 8 or not. For example, 8 ones are 8, 4 is carry 46. So 8 5s are 40, so 46 will not be divisible by 8. So this number is also not divisible by 8. Similarly, if the number is, let's say, 138128, then basically again we take the last 3 digits, that is 128, and then check by 8. Now if you look, 8 ones are 8, 4 is the remainder, so 48. So that means that 48 will be divisible. So that means that this number, entire number, will be divisible by 8. Similarly, if I want 16, which is nothing but 2 to the power of 4, then all I check is last 4 digits. So whatever the power of 2, if it is power 1, that is 2 power 1 is 2, so last digit, 2 square, last 2 digits, 2 cube, last 3 digits, 2 to the power of 4, 16, that means that last 4 digits. So it continues. If it is 2 to the power of 5, 32, then if I want to check the divisibility of 32, last 5 digit will be checked, right? Now that is one thing that you are supposed to understand. And then what is the logic behind it? It is very simple. Now when you know that, we have discussed in the remainder theorem, right? So now you just try to understand this. Now let's say if it is, let's understand for 4 and also for 8, that would be more than enough. Let's say if it is 132, this can be written as 100 plus 32. Now you know that 100 is nothing but, if it is having ending of a 20, that means that it should be having 2 pairs of 2 pairs of 5. So if it is having 2 pairs of 2, that means that it will be divisible by 4. So this part will be divisible by 4. Now if the entire number has to be divisible and it should leave remainder 0, then if this part is giving 0 remainder, this part is giving 0 remainder, then I want to make sure that this part is also giving 0 remainder, so that it is completely divisible. So I just need to check last 2 digits. Similarly, if a number is 3 digit, right, 1408, right, now this can be written as 1000 plus 408. Now what is this 1000? Since here this number is ending up with 3 zeros, you know that how when you will get end with 0 zeros, it should be a pair of 3 5s and 3 2s, right? So this is nothing but 2 into 2 into 2 into 5 into 5 into 5. So there are 3 pairs of 2 and 5 here. So since 3 pairs of series, this is 8. So this will be divisible by 8. So if this is divisible by 8, the entire number has to be divisible by 8 without leaving any remainder, only possible when this part is also divisible by 8. So this part anyways is divisible by 8. I need to check only for the last 3 digits. So that is the basic logic. Even for the 10, it is same. If it is, 15, it is nothing but 10 plus 5. 10 is already divisible by 2. All I need to check is for 5. If it is 115, this is nothing but 110 plus 5. 110 is already divisible by 2. So that means that I need to check with 5. So that is the same logic that we apply. So that means that for 2 to the power of 1 last digit, 2 to the 2 square last 2 digit, 2 cube that is 8 last 3 digit, 2 to the power of 4 16 last 4 digit, and so on. That is the rule for 2, 4, 6, 8 and 16 so on. Now for the next one, let's understand. Alright, 3 and 9. Right. For 3 and 9, what I am supposed to do? All I have to understand is, if you add sum of the digits, right, and that sum of the digit is divisible by 3, then the number is also divisible by 3. Similarly, if the sum of the digit is divisible by 9, then number is also divisible by 9. Right. So that means that, let's say if I am having 132, right. So whether it is divisible by 3, you don't need to check. What we are going to do, add all the digit cavities given. 1 plus 3, 4, 4 plus 2, 6. So this will be divisible. If 6 is divisible by 3, then the entire number will be divisible by 3. Similarly, let's say 144. All I have to do is 1 plus 4, 5, 5 plus 4, 9. So if this 9 is divisible by 3, then 144 is also divisible by 3. Right? The same logic applies for 9 also. If a number is 144, again, 1 plus 4 plus 4, that is 5 plus 4, 9. So if 9 is divisible by 9, then this 144 is also divisible by 9. You know that 16 9s is 144. So it will be divisible by 9 also. And also if it is divisible by 9, it is also divisible by 3. Right. So that means that all you have to do is add the sum of the digits. So once the sum of the digit, if it is divisible by 3, number will be divisible by 3. And if the sum of the digit is divisible by 9, then number is also divisible by 9. And so on. Right. So but one small trick that you have to understand when you are calculating, because this is something usually students mess it up. Let's say if a number is something like this. Okay, 4, something like this. Now if this is a number, I want to check whether this number is divisible by 3. Right. So then adding 1 plus 3, 4, 4 plus 4, 8, 8 plus 5, 13, 13 plus 6, 19, 19 plus 7, 26, 26 plus 8, 34, 34 plus 9, 43, 43 plus 9, 52, 52 plus 4, 56. Let's have one here, plus 1, 57. Okay. Now 57 is basically divisible by 3. Right. So, but adding this much, if you do one calculation mistake, then the entire calculation can go wrong and you may end up doing the mistakes. So what is the way out? Always when you are having this kind of larger number, don't try to add all the digit. Try to make a group of number which is multiple of 3. For example, let's say 3. It is already multiple of 3. So this number you don't need to add. 9. It is already multiple of 3. You don't need to add. 9. It is already multiple of 3. You don't need to add. Now if you look at here, 4 plus 1 5 plus 1 6. So if I make a group of 4, 1, 1, that becomes 6 again, which is multiple of 3. Again, you don't need to add them. Now if you look at it, I will be left with, let's say 6 already multiple of 3. You don't need to add it. Now 7 plus 8 is basically 15, which is multiple of 3. That is a separate group. Again 5 plus 4. That is 9, which is multiple of 3. So like that, you try to make the numbers in a group in such a way that they become multiple of 3, or if you are checking for 9, then you try to make a group in such a way that they become multiple of 9. Right. So again you will understand with one more problem. For example, 7, 8, 5, 4, 3, 2, 1, 4, 3, something like this. Now what you have to do? 3 is already divisible by 3. So you don't need to add this number. This 3 is also divisible by 3. You don't need to add this number. Now 2 plus 1. This is also 3. You make a group. This also you don't need to add. Similarly 4 plus 5. That is 9. So already divisible by 3. You don't need to add them to your overall calculation. Similarly 8 plus 4. 12. Which is again multiple of 3. You don't need to add them. Again that means that what is left? 7 is left. Just check with 7. If 7 is divisible by 3, no, it will leave 1 as the remainder. So that means that the entire number will not be divisible by 3. You don't need to add 7 plus 8, 15, 15 plus 5, 20, 20 plus 4, 24 plus 3, 27 plus 2, 29 plus 4, 33, right? Like that, you don't need to, keep on adding the numbers. Rather than that, make a group in such a way that they become multiple of the 9 or 3 as per the, requirement, right? So then add the number, right? So similarly, if the number is something like this, something like this, and I want to check whether the number is divisible by 9 or not. Now you know that 8 plus 1, 9, multiple by 9. So this is one group, you don't need to add them. Similarly 7 plus 2, 9, you don't need to add them. Now 4 plus 3, 7, 7 plus 2, 9. This is also another 3 number ka group which is making 9. So that means that entire number is a making of 999. So if you add them also, they will be multiple of 9 and this will be divisible by 9. You don't need to add 3 plus 7 plus 8 plus 2 plus 1 plus 4 plus 2, that you don't need to know, right? So that is another thing that you are supposed to have a broader understanding. So we have done with 2, we have done with 3, we have done with 4, right? 5 we have not done it, 6 we have not done it, 7 we have not done it, 8 we have already done, 9 we have already done. Now 10, it is very easy. Any number that is ending up with 0 will be divisible by 10, right? So that is, any number that is divisible by 0, you have to check. I mean, that is, sorry, any number that is ending up with 0 will be, basically divisible by 10, right? Since 11 we have not checked, 12 we have not checked, and so on, right? 13 we have to check, 14 and so on, right? So that means that now we go for 5. 5 is same logic again. All you have to check is the last digit for 5. If the last digit is divisible by 5, then the entire number will be divisible by 5. That means that how will you know if a last number is a number is ending up with 0 or 5, then number will be divisible by 5. That is 375. Last digit is 5. If this 5 is divisible by 5, that means that the number is also divisible by. So the last number, if it is ending up with 5 or 0, number will be divisible by 5. But if it is 374, then the last number is 4, which is not divisible by 5. So that means that entire number is not divisible by 5. So again, just like 2, for 5 also, all you have to check is last digit. Similarly, 5 square 25, right? For that, basically you have to check last 2 digits. Again, what is the logic? If it is, let's say 125, you know that 125 is nothing but 100 plus 25. 100 means already number is ending up with 2 zeros. When number will end with 2 zeros, for every 0 we need a pair of 2 and 5. So that means that this is 2 into 5, this is 2 into 5. That is making it 100, right? So that means that this part having 2 5s, that is 25, this part will be divisible by 25. Now all I have to check is whether this part is also divisible by or not. So last 2 digit would be sufficient to check. So if the 25 is divisible by 25, that means that 125 is also divisible by 25. So all you have to check is last 2 digit. If the last 2 digit are 0 0, then the number will be divisible by 25. If the last 2 digit are 25, then the number will be divisible by 25. If the last 2 digit are 50, then 50 is also divisible by 25. If the last 2 digits are 75, then also number is divisible by 25. Same goes with the rule with 5 cube, that is for 125. If you want to check, last 3 digit has to be checked. If the last 3 digit is divisible by 125, then the entire number is divisible by 125. The logic remains same. That is, the first part 100, 10, all these are divisible by 5, 25 because of the pairs of 2 5s and 2 2s and so on, right? So that is the logic. So that means that you have done with 5, right? 5, right? 2 4 5, then also 9 8 10 you have done with, 25 you have done with, right? Now let's understand the remaining numbers. Next is basically 6, 12, let's say 15, all these numbers. Now, if you look at these numbers, these are basically, having two different, they are basically multiples of two different numbers, right? For example, if I am having 6, 6 can be written as 2 into 3, right? Similarly, 12 can be written as 3 into 4. 15 can be written as 3 into 5. Now, understand this, whenever number is not a prime, always make sure that you write them in such a way that they, the multiples or the factors of those two numbers do not have any common factor other than 1. That means that you have to make them in such a way that they become a multiples of two co-prime number. What are co-prime number? If the two numbers are having, any factor which is other than 1. I mean, it do not have any factor other than 1. Such numbers are called co-prime. So always divide such numbers into, multiples of or two co-prime numbers. So that means that it's a very simple logic, right? So if you want 6, 6 can be written as multiple of two co-prime numbers, 2 and 3. So that means that if a number is divisible by 2 also, if a number is divisible by 3 also, then the entire number will be divisible by 6, right? Now, let's say if it is 12, 12 can be written as 2 into 6 also, but 2 and 6 are not co-primes, because apart from 1, between 2 and 6, there is another common factor which is 2. So that means that co-prime should have only one common factor between them, that should be 1. That means that you cannot write 12 as 2 into 6 for our calculation purpose. How I can write 3 and 4? Now between 3 and 4, what is the common factor? That is just 1. So when I write them into multiple or the product of two co-prime numbers, then I can say that if a number is divisible by 3 as well as 4, then number will be divisible by 12. Right? Similarly, 15, try to write them into the product of two co-prime numbers, which is 3 and 5. Right? So it can be written as 3 into 5. If a number is divisible by 3 as well as 5, right? Both 3 as well as 5, then the number will be divisible by 25. Now, similarly, if somebody is asking you the rule of 24. Now, 24 can be written as, for example, 2 and 12 also, but 2 and 12 are not co-prime, because apart from 1, between 2 and 12, 2 is a common factor. I can write it as, for example, 4 and 6 also. Between 4 and 6, apart from 1, 2 is a common factor. So, you cannot write them in the product of two co-primes. So, I want to write them in the product of two co-primes. So, I can write it as 3 into 8. Between 3 and 8, there is no common factor. We divide both 3 and 8 except 1. So, when I write them into the product of two co-prime, then the rule is it has to be divisible by both 3 as well as 8. If a number is divisible by 3 also, 8 also, then the number will be divisible by 28. So, if somebody is asking whether 96 is divisible by 24 or not, I check for 3. If you check for 3, 9 is divisible by 3, 6 is also divisible by 3. So, 96 will be divisible by 3. Similarly, I want to check with 8. 8 ones are 8. 1 carry forward 16, 8 twos are 16. So, it will be divisible by 8 also. It is divisible by 3 also. That means that 96 will be divisible by 24. That is product of both 8 and 3, that is 24. Similarly, if a number is, let's say, if a number is 36, right? Try to write the 36 into two co-primes, right? So, I can write 9 and 4, right? Both 9 and 4 are not prime, but they are co-prime because they do not have a common factor other than 1, right? So, that means that if a number is divisible by 9 as well as a number is divisible by 4, then number will be divisible by 36. Same rule goes for 12, 15, 14. If you want to have 14, then write it as 2 into 7, which are co-primes. Right. So, if the number is divisible by 2 also, 7 also, then number will be divisible by 14 also. Whatever the number they are giving, if they are giving you 40, all you have to check is make sure that 8 and 5, right, they are co-prime. So, if the number is divisible by 8 also, then 5 also, then number will be divisible by 40, right. Okay. So, we have done with 6 also, right, 9 also, 10 also, 12 also, right. Now, we are left with 7 and 13. See, for 7 and 13, right, there are two basic rules, but one rule is little complicated in a sense that it is having no logic. That is, what you have to do, you have to take basically, last digit, then multiply with 2 and then add it to the remaining number. You continue the process and keep checking whether it is divisible by 7 or not. So this is something which, is illogical, because the number is larger. Every time you do it, you have to do it 10 times. It will, it finds no error. It will not serve any purpose. So what is the another way to do it? Right, for 7 and 13, all you have to do is, let's say 1, 2, 3, 4, 5, 6, 7, 8, 9. Right, so let's say this. You take last 3 digits and next 3 digit. You subtract them. You take the difference between, make the digits of 3, 3. From the right hand side, you start making the group, make the 3 digit, 3 digit. Then find the difference. Right, whatever the difference here, for example, 789 minus 456, whatever the difference that you are getting, you add it for the next set of 233 digits and the difference between 233 digits. Let me give you a larger number so that you have a better idea. Right, 1, 2, 3, 4, 5, 6, 1, 2, 3, 7, 8, 9. Right, so let's say we are having this. First, this is a 3-digit ka group. This is the 3-digit ka group. Find the difference between 789 and 123. Right? Then you add it with next number. That is, next group is 456 and another group is 126. Here also you have to find the difference between 456 and 123. Right? So this is one difference, this is one difference. Then add that difference, see the sum. And whatever the result you are getting, you basically check what that result is, whether it is divisible by 13 or 7. Okay. In a realistic term, you don't need to find it, but if it's a larger problem, then you will understand how to do it. Right. All you have to do is taking, 3 digits from the right hand, again 3 digits from the right hand. You have to subtract them, then add it with the next group of 3 numbers. That is 3 minus next 3. That difference has to be added. So every time you take the difference of 6, and then you keep on adding that product till you get the final number. Right. So that is how we are going to do it. Both it is for 7 also and it is for 13 also. Then finally for 11, right? 11 is very easy. 1, 4, 5, 6, 7, 8, 9, something like this. You have to take, from the right hand side again, keep on adding the alternative digits. Okay. 9 plus 7, 16. 16 plus 5, 21. 21 plus 1, 22. Similarly, you add alternative digit here. That is 8 plus 6, 14. 14 plus 3, that is 19, 17. Right? You subtract this. That is the difference between sum of the alternative digit. So that is all the even position digit has to be added. All the odd position digit has to be added. Whatever the sum you are getting, you take that sums and take the difference between that sums. If that sums difference, if it is divisible by 11 or if it is 0 also, then the number will be divisible by 11. For example, we have a small number here, 1, 1, 3, 3, something like this. Here if you add 3 plus 1, 4, 3 plus 1, 4. So 4 minus 4 will be 0. That is sum, you have to take the difference between those sums. Then that is 0 or multiple of 11. For example, if I want to take multiple of 11, just have a, one, let's say I'll have 9 here, I'll have one more 9 here. Okay. Now 9, 9, 18, 18 plus 1, 19. Right. From 19 I have to write, say this is a number, 14949. So now if I want to add alternative 9 plus 9 plus 9, that is 18 plus 1, 19 minus other alternative, that is odd position, 4 plus 4, that is 8. Add the, those in the odd place, those in the even place, and then take the difference. That is 19 minus 8 will be 11, which is multiple of 11. So if the given difference is basically multiple of 11, then the entire number will be divisible by 11. So that is for your 11, 7 and 13. That's it basically, right? For 17, 19 and other numbers, our rules are there, but they are not really useful. It is better that you calculate them manually. Right? Now let's see some of the problems and solve how it is being given. Right? Now Let's go one by one. X, Y, Z or any choice of value. It is a 6-digit number in the form of X, Y, Z, X, Y, Z. And this number is divisible by, right? Now, one thing. First, we'll understand the rule for, let's say for 7. What is the 7 rule? Take the 3-digit X, Y, Z. Next 3-digit, again X, Y, Z. Right? What is the difference? Difference is 0. So, if the difference is 0, then automatically I can say that this will be divisible by 7. Either if it is 0 or if it is multiple of 7, then the difference, I can say that the number is divisible by 7. Same, x minus yz, x, y, z minus x, y, z, that is these 3 digit, it will be becoming 0. So, that means that it is also divisible by 13. So, it is divisible by 7 also, 13 also. Now, what is for rule for 11? 11, all you have to do is, right, x, y, z, x, y, z. So, I have to add alternative digit z plus x plus y, z plus x plus y. This is 1 minus y plus z plus x, y plus z plus x. Now, if you know minus y plus x minus z minus z, everything is get cancelled. So, answer is 0. So, that means that it is also divisible by 11. So, number will be divisible by 7 also, 11 also, 13 also. Now, in the exam, let's say if you are not getting the logic, then what you have to do? Anyways, they have told any values of x, y, z, just take any value 1, 2, 3, 1, 2, 3. Then check with them whether it is applying or not, right? So, that is first. Second, let x be a positive integer such that 7x plus 96 is also divisible by x. Now, how many values of x are possible? Right. So, now 7x plus, now one thing they have given is, it is a positive integer. That means that natural number, it cannot be 0, x cannot be 0. Only this much has to be understood. Now, try to understand the logic. Now, when you know a number has to be completely divisible, that means that it will leave remainder 0. So, that means that if I divide them, 7x plus x as well as 96 by x, this 7x is already multiple of x. This will be completely divisible by x. So, that means that this will leave remainder 0. Now, to get the entire calculation remainder 0, that means that completely divisible, this 96 should also be completely divisible by x. So, that means that 96 should be divisible by x. So, what are the numbers that will divide 96? That you are supposed to think. Now, that means that all the factors of 96, how many factors are there for 96? Right? 96 is nothing but, let's say 12 8s are, 12 is nothing but 2 cube. Then 12 can be written as 3 into 2 square, that is 4. So, basically this is 2 to the power of 5 into 3. Right? So, to the power 1. So, if the 96 can be written as 3 to the power of 2 to the power of 5 into 3 to the power of 1. Now, if you know how to calculate number of factors, that as we have discussed in the previous, take the power, add 1 to it. That is 5 plus 1, 6. Similarly, 3 to the power of 1, 1 plus 1, 2. 6 into 2 will be 12. So, there are 12 factors. That's it. Right? So, just, having two concepts. Now, again, writing n is formed by, a number n is formed by writing 9 for 99 times. That is, you are writing 9, 9, 9, 9. How many times? 99 times you have written. What is the remainder if n is divided by 13? Now, if I want to divide this by 13, what will be the remainder? Now, you understand the logic. I have written something like this. 9, 9, 9, 9, 9, 9. Something like this, right? So, what you are doing, here also 9 are there. So, what I am doing, what is the rule for 13? I take a group of last 3 with the next 3 and find the difference. Again, I will add the difference with the next, set of 99999. So, I will take these 999, this 999, I will see the difference. This is 0 difference. Again, next 999, next 999, I will see the difference. And I add that difference with the previous difference, right? So, this is also 0. Like that, for every 999 I am doing, I am getting, 6 9s giving you 0. Next 6 9s again give you 0. Like that 99 nines are there. So that means that up to 96, that is 16 6 is 96. So I can make 16 groups of 6 6 6 8, which is giving 0 0. Finally, last 3 nines will remain. Right? 1 group, 2 group, 3 group, like that I can make 16 groups, because for each group I am having 999, 6 nines. Again 999, 6 nines. So total 6 6 nines I can make 16 group. 96 9 is done. Each group is giving difference as 0 0 only, because here also 999, here also 999. So after that, last 999 will be left. So that means that how much will be left with you? 999. So the difference is 999. Now you check the remainder when you divide by 30, right? Because this will be completely divisible. Last 999 when you divide by 13, 13 7s are 91. So that means that 8 will remain. It will become 89. Again 13 6s are 78. That means that 11 will be the remainder, right? So this is also another logic. Now these two are the practice question. The number 3798125 P369 is divisible by 7. What is the value of digit P? Okay, answer is 1 6 7 9. Next, how many 5-digit prime number can be obtained using all the digits 1 2 3 4 5 without repetition of digit? That means that you cannot have just 3-digit or 4-digit. All 5-digit has to be used, and you cannot use the same digit twice. That means that 1 1 2 2 like that you cannot use. You have to use all of them only once. Order does not matter. You can use it as 1 2 3 4 5. 5 4 3 2 1 1 5 4 3 2, whatever the way you want to use, you can use it, but all the 5-digit has to be used. There is no repetition of digit. Now if you use it, how many prime numbers can be obtained? So this is the question. Think logically and answer this. And the last question, let XYZ be a 3-digit number where X plus Y plus Z is not multiple of 3, right? That is, some of these numbers are not multiple of 3. Then XYZ plus YZX plus ZXY is not divisible by which of the following number, right? 3, 9, 37, X plus Y plus Z. This you are supposed to calculate. Now, in these kind of problems, always it is better that, what you are supposed to do is think about it. If you are not getting it, then the logic would be assuming a number which satisfies the given condition and check with the numbers. All right. So that is with the divisibility rules. So hope you have liked the video, and if you have really understood the concept, then please solve them and write the answer in the comment. Also like the video if you have understood the concept, right? So in the next video, I am coming up with LCM and HCF. From there, our number system chapter will get over. From there, we are moving to the next chapters like ratio, proportions, percentages. Again, part of basic numeracy at large, but however, not the number system, where we'll have 2 classes for 1 chapter, so that we will start finishing. I'll have a larger like 1.5 hours per session for each topic, so that we can finish them, right? So for next week, we'll starting with more aggressive or the classes which we can finish at the large level, right? All right. So see you in the next video, guys. Take care.